We have already discussed a little bit some basic logic operators such as AND, OR, and these operators can be used to construct what's called logical expressions. Now let's discuss where and why they are used. The main thing here is that logic operators are required for us to check conditions. The conditions are necessary in turn to create branching programs. Let's say you have a question where you need to tell which one of two numbers is larger. So that's a very simple logical test. Let's say that you have number A, and let's assign some value to it. And then some variable B, and let's say it will be 10. Now let's suppose that we need to check which one of these numbers is greater. And if A is greater, then we want to print a message that will say A is greater. And if B is greater, then we need to say that. Let's first briefly detour for output function that we're going to use here. It's called print, and this is a standard function that you don't really need to import. You can use it to output some information. In Jupyter Notebook, the output of print appears right after the cell in which it was executed. If you were to just type some string, it will appear after the cell in which it was executed. The difference between these two options is that print cell didn't return any output. So if you were to check our output dictionary, you will actually see that it is set to none. Actually, in this case, it doesn't even exist in our dictionary. That is because print as a function does not return any value, and it just takes the string, or actually any number of arguments, and it will print them. As you can see, in this case, it just concatenated these three arguments together with a space. We will talk a little bit more about formatting and string operations in future, but right now that's enough for you to understand that print function is a very simple way to output data. This print function will print string to what is called standard output of your program. If it is a Jupyter Notebook, it will display it right after the cell. If it was a program, it would be displayed in the console. Okay, let's say that we need to test these numbers. How do we do that? In order to do that, we need to first figure out which of these numbers is actually greater. So let's do a simple calculation using the greater operator. Let's define a new variable that we will call condition A is greater than B. And let's assign A greater than B to it. And currently the result is false, because A is not greater than B. Let's change it and check for A equals 15. Now it returns true. We can compute whether it is true or false. What we can do with that? So in Python, like in many programs and languages, there is basic syntax for branching. For example, if statement. If statement takes the following form: if condition, colon, true statements, else, colon, false statements. This is a pseudocode. This will not be able to run, obviously, because this is syntactically incorrect. So we will have to fill this form. So we first need to write our condition. Our condition is this logical variable. And don't forget the colon at the end. Now let's add actual actions that we want to be executed. So in case this statement is true, we want to print A is greater than B. Otherwise, we want to print A is smaller or equal to B. Now if we run this cell, it will work. And as you can see, it correctly displayed that A is greater than B for A equals 15. And if we join everything into the single cell, we can now change value for A and test for other value. Now, as you can see, A is smaller than or equal to B. And the same will be displayed even if A is 10 and B is 10. Now, this is one important thing about syntax in Python. Both of these statements, this one and this one, they are now placed on a new indentation level. And this is mandatory. So there is no way to just say like this and leave them on the same level. The Python will not understand. The reason is because Python does not have any other markers for beginning and ending of conditional statement blocks. For example, in C that would be figure brackets. In some Pascal languages, then it will be begin and end statements. In MATLAB there are also begin and end statements, and this is quite a frequent thing. But in Python there are none. And instead, in Python, people use indentation. And this is mandated by the programming language itself. So it is enough in principle to just have one space offset from the previous level. However, you can see that print is now in red. That is because Jupyter Notebook suggests that we actually should use 4 all the time. So every time we need to make a new indented block, we have to add 4 to the previous indentation level. When you are writing scripts, you can use any number, but it is recommended to keep it consistent, and even better if you keep it 4, because 4 is basically the golden spot. It is not long enough to make your lines grow very far from the beginning and force you to write very blocky code. And on the other hand, it creates enough visual difference in the levels so that you can clearly see when one block starts and when the other ends. For example, if we were to add another if statement inside of this one, and we were going to test, for example, if a is greater than 0, then we can also do it inside of this external condition. And this block will only be executed if both conditions are true. This is how it will look like. If a is greater than 0, colon, the new indentation level, Jupyter Notebook does this automatically. And now we add print statement that will say that yes, a is greater than 0. And as you can see, because a is smaller than or equal to b, this part, the upper part, the true statements are not executed, and thus this condition is never tested and the print function is never called. Also, as you can see, the else block is actually optional. You don't have to use else block with every if statement. Let's change our conditions. Let's say that a equals 15 and run it. And now, as you can see, we have both lines printed. So a is greater than 0 and a is greater than b. And basically this means that all these 3 lines are basically inside of this true part of the if branching statement. And this line is also inside of true part of this branching statement. And this line is part of false part of the external branching statement. The next obvious question is, can we have more than one statement? And the answer is yes, and we already have done here. So these 3 lines are technically in the same statement block. So to give a more clear example, we can add a line here that will just assign a new variable with value a divided by b. And let's add some default value for c, for example, 0. And let's print c at the end of this. And now, as you can see, the first part has been executed, so c is still 0, and this line has never been executed because it is now part of the false statement. And if we change our condition, then this part is executed and both lines are active. So we both print the a is smaller than or equal to b statement, and then we compute c by dividing a over b. One more thing to mention about these conditions. As you can see, the first condition statement is actually stored first in the variable, and we are testing the variable. And the second one is actually written as equation directly. And in both cases, these resolve to some Boolean variables, so it is either true or false. The conditions don't have to be Boolean. However, they will be transformed into Boolean anyway. So for example, if you will write if and then 1, testing whether 1 is true or false, like this, then the second part, the false statement, will never be executed because 1 is what is called truthy statement, and it will be always converted to true in Boolean calculations, and thus this part will always be executed and this part will never be executed. And in principle, This is a stupid piece of code because you don't really want to have a statement that is never executed in your code. This is effectively removed lines. But in some cases, this is a good approach to test your code. For example, if you are suspecting that some condition check might not be working, you can substitute the whole condition with either true or false or truthy or falsy statement like 1 or 0. So as an example, if we run this now, this part is executed because 1 is truthy statement. And if we run if 0, then 0 is falsy statement and it will be converted to false all the time. And then we'll run second part. One important difference to some other programming languages is that -1 is actually a truthy statement. In fact, every number that is not 0 is evaluated to true in Boolean. Also, none as a constant has its own conversion. So if none is a falsy statement and it will always execute false branch. This is helpful for testing if some of the values are set to none without actually writing the whole variable is none test. But that is a little bit dangerous.